Good morning. This is Mr. Housen. We're looking at Newton's second law today. Newton's second law is a really easy extension for everyone who's already taken a look at how to find the net force on an object. So let's take a look at page number 8, the top few problems. So the first problem is a 50 kilogram box. It is, we believe, maybe just sitting there in space, maybe on a table. And for argument's purposes, we're going to say that there's only two forces acting on it. We're going to say that there's a force applied that's 150 newtons, and there's another applied force of 150 newtons, both to the right. So skills that we've already developed is that we know how to add these up, right? The sum of the forces is nothing more than 150 newtons plus 150 newtons. You can do this in your head, is 300 newtons. And that is informative, but it really doesn't tell you how or what happens because of that net force. So what we're going to do is we're going to take a look at a new formula today. And we're going to make it a little bit darker, a little bit bolder. Newton's second law says that the acceleration, that's a little too big, is equal to the sum of the forces, or the net force, directly proportional to the net force, and it's inversely proportional to the mass. So now what we're going to do is we're going to plug in our sigma F, 300 newtons, and divide it by 50 kilograms. And that looks like that is going to be an acceleration of 6 meters per second squared. So this object is being pushed to the right, and we know that because the two forces are to the right. And the acceleration is always the same direction. So what we'll do is we'll just simply say to the right, and of course the net force is to the right. So that's how easy these are to set up. Let's try that with another one that's a little bit more complicated, but not too much more. So in the second one, I see a 100 Newton force applied to the left, and I see a 200 Newton force applied to the right. So when you add those two forces up, we did that easily last week. That's a 200 Newton minus 100. And we get, of course, 100 newtons. And then let's apply Newton's second law. A is equal to the sum of the forces over the mass. How big is it being pushed divided by how massive it is? And we get 100 newtons over a mass of 50 kilograms. And now the acceleration is only 2.0 meters per second squared. Now, the final step, just to make sure, we know that the bigger force was the one on the right-hand side. So think of it as a tug of war. So the net force was a positive 100. And so the whole system, the crate, also must accelerate to the right 200. Let's do one last one and see if you're got the hang of this. What would be the net force with a 100 to the left and a 400 to the right? If you said that the sum of the forces is 300 newtons to the right, you're getting this kind of intuitively. That's great. 400 minus 100. And then the acceleration is the sum of the forces over the mass, or 300 over 80. Or 3.75 meters per second squared. Okay, so all of them so far have had a net force that was positive or to the right. Oops, I made a mistake there. Right, 400 is bigger than 100, so the net force was 300 to the right, so the acceleration is also to the right. The next one, in that second row, I believe it's number 5, has a situation where the net force is now negative 50 and 150, but both negative, so negative 200 newtons. A equals sigma F over m, negative 200 newtons over a mass of 60, which I get as A is equal to 3.33 meters per second squared. Of course, it's negative. And just a note, right, this is now a force to the left, so the acceleration is to the left. Hope that gets you started. Good luck. I certainly want to answer questions, and I'll be looking for your submission online. Good luck, ACP Physics.